Okay, the next problem I look at is something slightly more complicated, taken from exercise 17d2. What this does is it uses the chain rule, but we're still looking at the same problem of trying to find the gradient to the tangent. Okay, so I'll look at exercise. So I get my pen back. There we are. Okay, exercise 17. Let me just write that down. Is exercise 17d2, and I'm going to look at problem number 3e. That looks like a nice hard problem to do. Okay, so what we've got is a function y is equal to 4x plus 2 root x, and we need to find the gradient at the point x is equal to 4. Okay, that's the problem. How do we go about it? Just looking at this function, what we need is you need to use the chain rule to try and or not to try, but use the chain rule to find the first derivative. Okay, so we know the chain rule as dy dx is equal to dy du dx, where we use u as a sort of a halfway or an interim function to make the mathematics a little easier. So if we define right on this side, okay, just for clarity, if we decide that u is going to equal x plus 2 root x, that would make y now equal to 4 on u, okay, which is equal to 4u minus 1. Okay, just expanding this side a little bit, we get x. Again, it's the same as saying x to the power of a half. Okay, remembering that that means the square root of x. Okay, so now what we can do is find du dx, which gives us 1 plus, I'll just bring out the half out the front just to show you the working out, x minus a half, which is now equal to 1. These obviously cancel, plus x to negative a half. We can rewrite that as 1 plus 1 on x. Okay, and on this side, just separating that, we find dy du, which is equal to, bring the minus 1 out the front, got the 4, u, just to show the working out, minus 1, which now gives us minus 4 u minus 2. We can rewrite that as okay, so now we have both dy du and du dx, which is needed for our chain rule. Okay, so we can just putting these in there, we have dy dx is equal to first dy du, which is minus 4 on, okay, that's the first. Then we have du dx, which is that function there, bringing it over there, 1 plus 1 on x. Okay, so now we have the derivative dy dx represented with a u term in there. We know what u means from up here, so we just take that and substitute this back in. So now dy dx is equal to Just keep the brackets there to keep things organized. X plus 2 square root of x. Let's not forget this whole thing is squared. Okay, close that. Let's look at it on this side. Nothing changes here. Now we need to find the gradient at x equals 4, making the substitution in there. Dy dx is now equal to minus 4 plus 2 square root of 4 squared 1 plus 1 on 4. All starts looking a little bit messy, but hopefully we get to the right solution. So we now end up with minus 4 over 4 plus 4, 8 squared gives us 64, and over here we can rewrite that as, so this here is equal to a half. I could rewrite that as 3 on 2, giving us the grand number of minus 12 over 128. Okay, and if we were to simplify that a little bit further, okay, we could simplify this a little bit more. Instead of leaving it as this larger number, we could break this down. This is equivalent to if we do 12 divided by 4, 3, and 128 divided by 4 is 32. Okay, that's in its simpler form, and I believe that would be the final correct answer.